Now we continue our solution by separating the angular part into a polar and an azimuthal part. So the angular part into theta and phi part. So we know that we have defined y of theta and phi as the angular parts. We can actually separate them into a linear function on theta times a linear function on, not a linear, a single variable function on phi. Okay, so now let's put this solution in our angular equation. So we would have times a equals 1 over sine theta, and then partial derivative with respect to theta of sine theta times plus 1 over sine squared theta times second derivative with respect to phi of times so simplifying this equation, we will arrive at this form. Phi over sine theta plus our separation constant a equals 0. Okay, so now, just like what we did earlier, we isolate the variables on this term and this term for the polar and the azimuth parts. So this step we will separate azimuth parts. Okay, so rearranging, we can have times sine of theta plus 1 over capital phi plus a sine squared of theta equals 0. So notice that this term is purely in polar variables, theta. Also this term. And this term is purely in the azimuth variable, phi. Okay, so now we assign again a separation constant. So let's assign a separation constant b. So we will equate b as the blue parts and the yellow part. Okay, so we would have b equals sine theta over d theta plus a sine squared theta, and for the other one we would have b equals 1 over capital phi d squared phi squared. So now we call these two equations the polar part of our angular equation and our azimuth part of the angular equation.